So good afternoon, everybody. I welcome all the participants of this webinar that will deal about nutritional strategy for healthy aging. So just I introduce me briefly. I'm Claire Gaudichon from Agro Paris-Tech in RAE Paris-Saclay in Paris, in France. I work on protein metabolism and digestion. So I will introduce a little bit this meeting before sharing the presentation of the speakers. So first of all, this meeting is supported by ILSI, so the International Life Science Institute that brings together experts from academia, industry, and health authorities who collaborate and share their unique expertise to reach consensus to improve public health. So this webinar was supported by the Health Benefits Assessment of Foods Task Force, and it is organized by ILSI Europe expert group who worked on targeted protein intake for muscle health. This meeting will review some very interesting topics regarding the effect of protein intake on muscle mass and muscle strength, also about the intake of omega-3 fatty acids and muscle function and muscle turnover, and then also about the link between protein intake at high level for the prevention of bone loss, especially during energy restriction. And I just present briefly the three speakers, but I will present more in detail before their presentation. So first of all, Dr. Everson Nunes from Hamilton in Canada, and then Professor Philippe Calder from University of Southampton, UK. And to finish, Sue Shapses from New Brunswick in USA. So we will start with the first presentation from Dr. Everson Nunes. Sorry. So he has a PhD in cellular and molecular biology. Is now on a postdoctoral position in the laboratory of exercise metabolism in the Department of Kinesiology of McMaster University in Hamilton. And his researches focus on the role of dietary and physical activity intervention in promoting changes in the regulation of metabolic pathways, and particularly in the goal to prevent non-communicable disease. And I think that's all. And now, Everson, you can. I will stop sharing the screen, and you can start your presentation. Sorry, yes. Now you can share your screen, and you can start your talk. Just to I give some information about the question. There will be a session of 5-minute session after each intervention. So please put your questions in the chat, and after I will pick up the question at the end of the intervention. And if we have time at the end of the meeting, the webinar, we can have an extra 5-minute session for all the other questions. Thank you very much.
Okay, thank you, Professor Claire, and thank you, ILSI, for organizing the webinar as well, and also thank you for everyone for taking the time to participate in this webinar today. Okay, so just want to take this out of the way here. So starting so my talk will basically go around this statement over here. If I eat more protein, my muscles will get bigger and stronger. And hopefully by the end of this webinar, you all will have some information to back this statement or not. So my idea here is to give you some evidence. And with this evidence, you all will be able to say if this statement is true or not. Okay. Before starting, I would like to acknowledge some of the funding sources we have in our lab. And it's important to disclose that some of these funding sources are associated with or related to the private sector. And if that's the case, they might benefit from the results of our research. So I'm not really sure if that happens to some of you watching this webinar, but there's something that happens to me all the time. Like every time I meet someone new, and we start talking about what we do, family and stuff, and especially when you talk about work. When I tell them I am a dietitian and I work with nutrition and research, is really common to someone to start asking questions about nutrition. And one of the top questions I get all the time is related to protein. So people want to know if eating more protein helps to build muscle. They want to know if eating more protein can make them stronger or can help them in any way to achieve something they have in mind, right? And but when I go to the gym, the story is a little bit different. So when I get there, usually what I hear is that it's something really close to the statement I put in the title of this webinar. So people are usually like affirming they believe like that eating more protein will help them to get bigger and stronger. So we have this really construct really different ideas. So on one side you have people that don't know if protein can help or not, and in the other side you have this other people saying that protein helps for sure. And all this is around the questions I put here in this slide for you. So uh, and they are really practical questions. When you start thinking about nutrition and protein and how protein can help muscle metabolism and can in some way be important for the skeletal muscle. Uh, a lot of people they want to know if eating more protein can help healthy people in any way, and this is important. It's important to realize that there's a lot of research on people with disease, and this research can show that sometimes it's really challenging to help these people to maintain muscle mass if they have some kind of diseases. But my talk today will be related to healthy people. So we want to know if protein ingestion can help healthy people in any way, for example, like building muscle or getting stronger. So the question is, does it work in healthy people? And I'm going to try to show you some evidence about that. And another relevant question is, let's say it works, but does it work in the same way for young and older people? And this question is relevant because there's a lot of evidence showing that older people might struggle to maintain muscle mass over the course of the life, and is usually very common to see people losing muscle mass when they age. So a relevant question is, let's say you are just older and but you're healthy, and does protein can help you in any way to build muscle or to make you stronger? And so this question about like young and old is quite relevant. And let's say it works. Let's say protein can help you. But what about the real life results? Like how much muscle can you gain, or how stronger can you get if you start eating more protein? So it might be challenging to find the answers for these questions, especially if you are working in the nutrition field and you are just consulting patients, or you are blogging or doing something related, trying to just spread the knowledge out there. So uh, one important question is like how to find the answers to these questions, right? And one way to find this kind of answers, to find this answers is to go to the scientific literature and let's say read all the clinical trials that were conducted so far testing the effects of protein, and especially testing the effects of protein in healthy people. I can tell that this can be very challenging because we have hundreds of scientific journals out there available now, and in every journal you can have dozens and dozens of clinical trials published where different study groups compare the effect of protein, and they were investigating something related to muscle mass or muscle strength, and they were comparing this to a control or a placebo. So this will be like one way. Would be one way to try to find the answer. So reading everything that's available out there. So like I said before, this can be very challenging, and uh, even if you are able to read everything, how to summarize all your reading in one answer, how to put all these ideas together. So it's really, really difficult to work with this kind of information. So they look like simple questions, but in real life, it's kind of hard to have like a simple answer for that. So one way to try to find the answers in easier um, manner, I would say, is to try to find like uh, systematic reviews and meta-analysis where different scientists try to summarize the evidence and and try to find out like a common answer for these questions. And here in this slide, I have some examples of this kind of literature. So you can go on the internet and search for systematic reviews and meta-analysis because they are very important tools to try to summarize the evidence around any topic you are interested in. And here you have some reviews and meta-analysis on our topic. So all these studies here, they were in some way trying to find the answer to the question about the effects of protein on muscle mass, what I'm calling here as, I'm using the term lean mass as a proxy to that, and or also trying to find any effects of increasing protein ingestion on muscle strength. But when you start reading all these papers, you realize that it can get very complicated because when a researcher is writing a review, uh, the conclusions the researchers can get at the end of each one of the studies, they are very, very attached to the kind of studies they included in the review. So your criteria of inclusion for studies in these reviews can be very, very close to the conclusions you're going to get. And reading all these papers here, one thing that is very, very easy to notice is that sometimes uh, the authors don't mention they don't mention in the title, but you have studies where people were under protein deficiency before starting the study. So they were eating less than zero point 0.8 grams per kilo of protein per day, which is like the minimum amount of protein that's recommended for an adult person to eat to maintain health. So that would be the minimum, at least for if you are reading most of the recommendations out there. For other people, that can be it seems to that this value can be a little bit higher than that, but for most adults, the recommendation is still there, is still around this. So when you're reading these studies, you might find that some trials had people with protein deficiency before starting the studies, or sometimes you have trials where people were exposed to diet restriction, and then you have a weight loss study included in these reviews. Sometimes you have studies including obese participants, and one important thing is that there's some evidence showing that obese participants might be resistant to the effects of protein ingestion regarding uh, skeletal muscle metabolism. So they might not have a robust anabolic response after eating protein. And that can be an issue if you are trying to find your answer for healthy individuals. Sometimes you can have some studies where people had mobility issues. And this can be another challenge because if you're not able to move, non-moving is something that can affect your muscle mass, and testing protein under these circumstances can be challenging as well. So you're not really testing a 100% healthy person. And another challenge is that sometimes you have people with minor diseases included in these reviews over here. So if you have a minor disease, you might be resistant to the anabolic effects of protein as well. And putting all of this together, like my question is like how a typical person would respond to protein ingestion. So if this person has no diseases at all, enjoying a full mobility, and is not exposed to any dietary restrictions, how this person is going to respond to additional protein ingestion. So this is it's what I'm trying to answer here. So our lab a few years ago published this meta-analysis, and the main target there was to in some way answer part of our initial questions. So the main questions here were related to the effects of protein supplements on free fat mass and muscle strength. And in this meta-analysis, only studies where participants were exposed to resistance training as well were included. So after reviewing more than 3,000 studies, 26 interventions were analyzed for free fat mass gain, and 28 interventions were analyzed for strength gains. So the idea was to investigate if supplementing protein had any benefits. And what they found was that there was a positive effect for protein for free fat mass gain, and a positive effect for protein for strength gains as well. But as you can see here, I try to highlight the numbers here. So you have a positive effect of increasing protein ingestion, but the effect on free fat mass gain is about 300 grams more. So comparing the groups ingesting more protein with the control groups, the groups ingesting more protein were gaining 300 grams more. So yes, it's a positive effect, but the effect is not that big. And the same happened for strength. So people ingesting protein were lifting 2.5 kilos more when compared to people not ingesting protein. So positive effect, but the effects are not that big. In the same paper, one interesting analysis was this one over here in the left side. So this graph here shows the changes in free fat mass according to protein intake. This is daily protein intake. This is how much protein they were ingesting per day. And you can see that there's a trend to change your free fat mass according to increase in total protein intake. But this seems to go up to 1.6 grams per kilo per day of protein. So people were gaining more free fat mass, but after that, there is some kind of plateau over here, at least when analyzing the studies that were included in this analysis. And another interesting thing was that in this graph over here, they show that apparently younger subjects, so this is age on the x-axis here, this is age, so younger subjects were gaining more free fat mass when compared to older subjects, which is in line with the idea of some kind of anabolic resistance to the effect of protein in older subjects. Some years later, with the help of ILSI and some experts in protein ingestion and muscle health around the world, some members of our lab and some other folks from other departments and other sectors published this paper about 2 months ago. And the idea of this study here was to change, especially the inclusion criteria, to expand our knowledge in this field of protein ingestion and the effects on muscle mass and muscle strength. More specifically, if you remember the study I just showed you, there, like the question was regarding protein supplements, and only protein supplement, only studies testing protein supplements were investigated. But now in this study, the idea was to expand that to any kind of protein intervention, increasing protein intake. So not just protein supplements, but food in general as well, or any dietary manipulation that could increase protein intake. And of course, we included some secondary questions. The question about age was important to us as well. And again, we were trying to answer the questions regarding healthy participants, not participants with any kind of diseases. So in this study, we try to expand the age range to from 18 years old to 85 years old. So just healthy subjects, any kind of protein intervention. We need to have, like, every study to be included should have a control or a placebo group. And we are trying to investigate effects in lean mass or any kind of similar measure. So it could be lean body mass, muscle mass, bone and fat-free mass, so any kind of proxy measure of lean mass. And also we were investigating muscle function, specifically muscle strength, so lower body and upper body muscle strength, and also hand grip if this was something available in the studies. We tried to expand as well our search to include some studies where any kind of physical tests or performance in physical tests was assessed, like the speed you achieve when you are walking, like if you can, how long can you take for stand up from a chair, or how fast can you go up and down stairs. So any kind of physical test trying to measure some kind of muscle function as well. And of course, we try to restrict our review, including just randomized clinical trials. So after getting more than almost 9,000 papers to screen, we got at the end around 74 randomized clinical trials testing the effects of protein on lean body mass, strength, or any kind of functional and physical tests as well. From the 74, 66 investigated lean body mass, 34 bench press strength, which is like upper body strength, 50 studies lower body strength, 10 studies hand grip strength, and 15 studies functional and physical tests. After reviewing this 74 selected studies, one thing we noticed is that animal protein was the main source of added protein to people's diet. Most studies, they lasted about 8 to 12 weeks. And one interesting thing is that the baseline protein ingestion in most of these studies was about 1.2 grams per kilo per day. So people were already ingesting about 1.2 grams per kilo per day before starting the study. This was their regular diet, and especially if they were younger. And we didn't get any study where people were ingesting less than 1 gram of protein per kilo per day, even if they were old participants as well. So in all the studies, people were ingesting more than the minimum recommendation. And another thing is that the dose of protein was about 10 to 30 grams in 60 and 56% of the studies, and 31 to 50 grams in 80% of the studies. So going to the results, we saw positive effects of ingesting more protein in lean body mass, and we tried to analyze these studies according to using protein ingestion only or protein ingestion plus resistant exercise. One of the ideas of this study was to investigate the protein effect, the isolated effect of protein. But unfortunately, as you can see here, we found just 6 clinical trials using just protein. And with analyzing these 6 studies, there was a positive effect, but was not significant. When you analyze the protein plus resistant exercise, we have a positive effect of protein. So people were gaining more muscle mass. And this was about 0.5 kilo more muscle mass. You can see the forest plot here by your right. Forest plots are not PowerPoint friendly, so I know you can't read this. But if you access the paper, you're going to have access to the full data. And one important thing is that, like, you can see the age effect here. We found a significant effect for younger individuals, but not for older individuals. We try to analyze, to conduct the analysis as well by daily protein ingestion. And for the studies where resistant exercise was part of the protocol as well, we saw positive effects for ingesting more than 1.2 grams of protein per day. So if you were ingesting more than 1.2, we saw positive effects. But one important thing to mention is that there were not many studies where people were ingesting less than 1.2 grams per kilo. So we can't say that ingesting less than 1.2 doesn't work, but we for sure can say that more than 1.2 has a positive effect in lean body mass. And finalizing here with the results for strength, we have the positive effects of protein ingestion in lower body strength, in upper body strength, and also in physical and physical function, physical tests and muscle function tests as well. So the effects were positive, but they were quite small. And the only outcome that we found no significant difference here was hand grip. So summarizing everything, we don't have enough studies to say much about the isolated effect of protein. But when you are adding protein to resistant exercise, you can see some positive effects in lean body mass. That happens to young and older individuals. That happens as well for muscle strength and for physical and functional tests. But so far, not that much for hand grip strength. The take-home message will be, does protein works? Yes, but we don't have much evidence coming from studies where just isolated protein was tested. So we have more studies where protein was added to a resistant exercise program. And how big is the difference? Like how big is the effect of protein? Not that big if you are already eating more than 1.2 grams per kilo as a baseline diet, and also if you are lifting some weights. So what you do then? So we know that resistant exercise is the most potent anabolic stimuli for muscle mass and muscle strength. So this will be like the first recommendation for sure, even if you are young or old. And thinking about nutrition and protein itself, I would say that based on the data, you should eat around 1.2 and 1.6 grams per kilo, and that, when added to the resistant exercise program, will give you a little more, will give you a little gas to gain some muscle mass. If you are a little bit younger, you might add a little bit more than that, but the literature is not very clear about the real life effects. And with that, I would like to say thank you for everybody, and I'm happy to answer any questions.
Okay, thank you very much, Everson. So there are two questions in the chat. One about the link with the gut microbiome that can affect skeletal muscle mass. And there is a question, whereas there were studies regarding the effect of prebiotics and muscle mass or muscle strength in humans and in rodents.
Okay. Yeah, this is a very interesting field of research. Like, I had some experience working with this kind of research as well in the past, but mostly in obese participants. And there's a growing field showing that what we eat can change the microbiome as well, and this microbiome is producing a lot of molecules that can be really important to us as well. So there's a lot of research showing improve in insulin resistance, improve health overall. And especially if you're thinking about aging and you're thinking about some underlying diseases that affect us when we age, you're thinking about the low-grade chronic inflammation. This is something that happens with us when we gain some weight, when we age, and especially eating diets where you can improve your microbiota seems to be very important to regulate this low-grade inflammation over the years. And there's some research showing that when you do that, you can also improve the anabolic resistance that's present, especially in older subjects. So this is a very promising field. I don't have much reading about the studies testing this right now, so I can't give more information about that. Yeah.
Okay, thank you. There is also a question, if you can answer quickly, because we are a little bit late, about the effect on chronic kidney disease in older adults when you when you eat a protein above 1.2, 1.6 gram. What do you think about that?
Yeah, so there's a lot of research trying to find associations between high protein diets and the development of some diseases. Like you have research showing risks for type 2 diabetes, for some kinds of cancers, and also liver diseases, bone-related diseases, and kidney-related diseases. But the truth is that most of this evidence is showing that there's no direct evidence linking ingesting more protein to the development of these diseases. And maybe there's more in the diets of these people that can be like the main cause of this risk, if there is any, but not the protein itself. Yeah.
And perhaps last question, but perhaps there are additional questions in the chat, but there are questions about the effect of protein quality, the animal versus plant protein. What did you see, especially in the meta-analysis studies, whether the effect of protein quality could be addressed?
Yeah, like one of the questions we had in the plan for this meta-analysis was trying to search for the difference between animal and plant-based proteins. But unfortunately, when we were reading all the selected clinical trials, we saw that 80% of the studies, they use some kind of animal-based protein. And the studies that were using other sources of protein, they were using like mixed sources, so they were mixing plant-based with animal, and a very small amount, I would say less than 5%, used just plant-based proteins. And the studies that use plant-based proteins, they were using soy protein, isolated soy protein. So we need more trials actually to gather more information and show if this plant-based sources can produce the same effect when compared to the other studies we have so far with animal-based proteins.
Yeah. Thank you very much. There are other questions, but we have to give the talk now to Professor Philippe Calder. So Philippe Calder is professor in nutritional immunology, University of Southampton. And his expertise is about the metabolism of fatty acids, especially omega-3 fatty acids. And he will talk about the effect of omega-3 fatty acids on the regulation of muscle turnover especially. Thank you very much, Philippe.
Great, thanks so much, Claire. Hopefully you can hear me and see my slides okay. So my talk sort of follows on from Everson's talk, I think. I'm going to focus on experiments, particularly human experiments around omega-3 fatty acids, looking at protein turnover and muscle turnover. So as Everson sort of hinted at, there are many factors that influence protein turnover and therefore muscle turnover. That is the balance between degradation and synthesis. Of course, if you have net degradation, you will lose muscle mass. If you have net synthesis, you will build muscle mass. If degradation and synthesis are in balance, muscle mass will remain stable. So some of the things that can affect these processes are the amount and regularity of physical activity. Everson has actually just stressed that point, I think. Intensity of physical activity. Acute intake of protein has an effect on protein turnover, for sure. Long-term intake of protein, Everson has been talking about that. Insulin sensitivity is also important. The presence of disease, which maybe drives degradation over synthesis, so we get loss of protein and net loss of muscle, and age. So we can have age-related muscle loss related to a change in the turnover relationship. One of the common features of disease and age is an increase in low-grade inflammation. And it turns out that low-grade inflammation, in fact, high-grade inflammation also, drives loss of protein and drives loss of muscle. And here I depict just in general how that happens, or how it might happen. So, of course, there are multiple effects of inflammation. One of them actually is an upregulation of muscle proteolysis, so in other words, increased breakdown of skeletal muscle protein, but also anorexia, so decreased intake of food. So you have lowered protein intake in the face of an increasing muscle protein breakdown. The end result of this is muscle tissue loss, and the clinical correlate of that will be increasing fatigue, loss of mobility, impaired quality of life, and onset of illness. And of course, this is a common feature of frailty going into, or of sarcopenia, age-related muscle protein loss, going into frailty when it's combined with some other factors. This is common in diseases like COPD, cancer, and so on. Now, you'll be aware that the omega-3 fatty acids, EPA and DHA, are anti-inflammatory, so they decrease inflammation, but also they give rise to chemical mediators that are called specialized pro-resolving mediators. So that means chemicals made from EPA and DHA actually turn inflammation off. So this is a sort of a double whammy, if you like, decreased inflammation, but also the turning off of inflammation. And what that means, at least in theory, is that omega-3 fatty acids could be used to intervene in this process that I've described to you, to decrease the inflammation-driven drive to break down protein and to drive muscle tissue loss. And of course, if this is true, this could have enormous clinical benefits in aging and in people with disease. So I think we need to make sure, if this is going to happen, that the omega-3 fatty acids are getting to the places that they're needed. Now, you'll be familiar with the fact that if people increase their intake of EPA and DHA, we have more EPA and DHA in the blood and in blood cells. People talk about that all the time, the increase in omega-3s in red blood cells, white blood cells, and so on. There are fewer studies in humans in tissue, and there are actually rather few in muscle tissue. But here I show you two studies, and I'll talk about them briefly. I'll start on the left. Small study, 10 moderately active young males, given a very high dose of omega-3s, 3.6 grams of EPA and nearly a gram of DHA every day for 4 weeks, with muscle biopsies taken at 5 time points, before the intervention, when the intervention started, and then at 1, 2, and 4 weeks of intervention. EPA is in blue, DHA is in brown. So essentially going from 0 to 4 weeks, that is the increase in EPA in blue and DHA in brown over the 4-week period. So this study shows that EPA particularly gets into skeletal muscle when you give a high dose, and DHA also gets in, that's quite clear, although the increment is much smaller. Maybe that's related to the lower dose of DHA being used in the study. On the right is a similar study, 9 relatively inactive men and women, mean age about 40, a lower dose of EPA this time, but a higher dose of DHA for 8 weeks, again with a muscle biopsy before the intervention in blue and after the intervention in orange. And what we see is EPA goes up in the muscle over the 8-week intervention, and DHA goes up in the muscle over the 8-week intervention. So certainly giving people moderate to high doses of EPA and DHA drives the incorporation of those fatty acids into the muscle tissue. So that's a start. Now, it turns out this actually does have effects. It has biological effects within the muscle tissue. So these are data on protein expression in skeletal muscle biopsies from the study where the biopsies were taken at the start of the omega-3 intervention and at 1, 2, and 4 weeks. So here we see different signaling proteins. This is mTOR in the upper right, other signaling proteins in the muscle over that period of time. And if you look at the patterns, you'll see there seems to be an increase in these signaling proteins. It's not always statistically significant, but an increase in these signaling proteins when omega-3s are given. So for this protein here, there is actually a significantly higher expression at 4 weeks than at baseline. And for mTOR, there was significantly higher expression at 2 weeks compared to baseline. I think keep in mind, this is a small study and there's quite large variation between the individuals that maybe is covering up a little bit what might be happening here. But this is an indication that incorporation of omega-3s into skeletal muscle can affect the signaling proteins involved in muscle protein turnover and in muscle function. This is another study where people were given omega-3s for a period of 8 weeks. And in this case, muscle protein synthesis was studied using stable isotopes. Now, at the beginning of the study, they studied muscle protein fractional synthesis rate, as it's called, at baseline and following an insulin clamp. And of course, insulin increases amino acid uptake into muscle and increases muscle protein synthesis. So at the start of the study, there was a particular rate of muscle protein synthesis. When the individuals were given infusion, a continuous infusion of insulin, that rate of protein synthesis increased. That's exactly what insulin would do. They then went into this omega-3 intervention for 8 weeks. And at the end of the 8 weeks, the insulin clamp was repeated. And what the researchers identified was that in response to insulin, the protein synthesis rate was higher after omega-3s than it had been before omega-3s. So in other words, the conclusion was that chronic omega-3 fatty acid supplementation augments the anabolic effect of insulin that actually was given in the presence of infusion of amino acids. In other words, omega-3s seem to increase muscle protein synthesis in the presence of insulin and amino acids. So they help insulin make muscle protein. This is a really interesting study by Chris McGlory. I think this is quite a unique study in the context of my talk today. 21 active females, 19 to 31 years, were put into a trial of omega-3s, about 5 grams of EPA plus DHA per day. So this is a high dose study, or placebo for 8 weeks. So there's an 8-week period of supplementation with omega-3s or placebo. And in the middle of that 8-week supplementation, these individuals went through a period of 2 weeks of leg immobilization. So there's 8 weeks of supplementation with omega-3s or placebo, including a 2-week period of leg immobilization. And of course, if you're not using your leg muscles, you get net loss of muscle mass. So there's an increase in protein degradation and a decrease in protein synthesis, leading to loss of muscle mass. So on the left here, we see muscle volume, and on the right, we see muscle protein synthesis. Let's look at the left first, and I'll explain what we're looking at. The open bars are the placebo group, and the gray bars are the omega-3 group. And these are the differences in muscle volume at study entry compared to the end of the immobilization period. So during immobilization, the placebo group lost muscle volume. The omega-3 group also lost muscle volume, but the loss wasn't as great. So that must mean something about omega-3s was stopping the degradation of muscle protein and of muscle tissue. So there was maintenance of muscle during immobilization. On the right of the left-hand panel, we see the difference from study entry to the end of the study. So this is the recovery period. So the period before the immobilization, and then the 2-week recovery period. So at the end of the whole 8 weeks, the placebo group had lost muscle volume, but the omega-3 group had got back essentially to where they started. That was a statistically significant difference. Let's look on the right-hand side now. This is muscle protein synthesis. The difference between study entry and the end of immobilization, showing that in the placebo group, the immobilization period decreased muscle protein synthesis. That would be an explanation for why muscle volume was decreased. The omega-3 group also decreased muscle protein synthesis, but the effect was smaller, and this was a statistically significant difference. And then by the end of the study, the rate of muscle protein synthesis had actually returned to where it was at the start of the study. But again, this is a study showing that omega-3s can decrease the loss of muscle and can enhance muscle protein synthesis. So it's a different sort of study coming up with the same sort of result that the previous study with the insulin clamp had shown. So if you put these studies together, the effects of omega-3s on skeletal muscle are to alter the expression and activation of signaling proteins, to decrease muscle protein breakdown, and to increase muscle protein synthesis. So this would be a wonderful effect in the context of aging and in the context of many diseases, COPD, cancer, and so on. So I hinted at the beginning that the effect of omega-3s might be because of their anti-inflammatory action. So this is a scheme just showing that inflammation drives protein degradation. It also drives oxidative stress, and one of the response to oxidative stress is apoptosis, for example, apoptosis of muscle cells if the oxidative stress is in skeletal muscle. And what I put to you early on was that omega-3s would interfere with this inflammatory response, and that could have the effect of reducing the rate of protein degradation directly. But this scheme also suggests that omega-3s could have an anti-apoptotic effect in muscle, and that could also be part of their capability to reduce protein and muscle breakdown. This is a figure showing the same sort of thing from a review that Chris McGlory and I wrote. Again, we have the effect of omega-3s on inflammation over here, meaning that they might prevent the protein breakdown, but we also suggested that they have other effects which are not really very well described yet, but on these signaling proteins in muscle that mean they promote protein synthesis. Because remember, several studies that I mentioned showed an increase in protein synthesis. So I think there's this dual effect of decreasing protein breakdown and increasing protein synthesis, certainly with very high doses of omega-3s, that means they can be useful for maintaining and perhaps building skeletal muscle. So does it actually make any difference? So Everson has talked about meta-analyses and forest plots, and that what you get out is really a feature of the studies that are put in. This is a systematic review and meta-analysis that I was involved in, looking at the effect of omega-3s, that's EPA and DHA, on muscle mass and muscle function in sarcopenia. And on the left is the forest plot for lean body mass. So these are randomized controlled trials of omega-3s compared to control, showing that when all the studies are aggregated, omega-3 fatty acids increase lean body mass. This is lean body mass, so this is muscle, if you like, compared to control. And on the right, we see muscle mass. So this on the left is lean mass over the whole body. On the right is muscle mass. again showing when the studies are aggregated, omega-3s increase muscle mass compared to control. But I think you have to look here at the heterogeneity of the studies. And this forest plot on the right is really interesting because it seems to suggest there are two sorts of studies. There are studies that show absolutely no effect of omega-3s, and then there are other studies that show an effect of omega-3s. And of course, when you aggregate all of this, you get something in between. And I think part of this heterogeneity is we included all studies of sarcopenia. And this could be age-related sarcopenia, it could be disease-related. Within the diseases, it could be an inflammatory disease like COPD, it could have been cancer, it could have been a severe cancer like pancreatic cancer, or a less severe cancer. So there's real heterogeneity here that I think explains the spread that we see. But nevertheless, this effect of omega-3s in randomized controlled trials in resulting in higher lean mass and higher skeletal muscle mass than control fits with the experimental studies that I talked about, showing that omega-3s promote protein synthesis and decrease protein degradation. So just to summarize, what I've told you is omega-3s are anti-inflammatory and they promote resolution of inflammation. Sorry, something's happening here. Can you hear me?
Yes, no, it's okay, yes.
Okay, sorry, I got a message that I was muted or something. So inflammation is a factor that drives muscle breakdown, that's muscle loss. EPA and DHA are incorporated into skeletal muscle when their intake is increased. They alter the expression and activation state of signaling proteins. I showed you one study about that. Chronic increases in EPA and DHA intake increase muscle protein synthesis in response to insulin and amino acids. That's a really nice study with clamps that I showed you, clamps and stable isotopes. Chronic increase in EPA and DHA decreases muscle loss and maintains protein synthesis during immobilization. Another really nice study. Of course, these are just a couple of several studies in the field. So these and other studies suggest that omega-3s favor muscle protein synthesis over degradation. And finally, I talked about a systematic review and meta-analysis where we aggregated randomized controlled trials in humans, demonstrating that EPA and DHA increased lean mass and muscle mass compared to placebo, but there were heterogeneous groups studied in the studies included in that meta-analysis. Thanks. Okay, so conclusion, sorry. EPA and DHA decrease muscle protein breakdown and promote muscle protein synthesis. This is a clinically important effect, although note that really high doses were used, but the full mechanisms underlying this are not actually known. Maybe we know more about why they decrease protein breakdown than why they increase protein synthesis. Thanks very much for your attention.
Thank you very much, Philippe. First, there are some questions in the chat. The first one is about the doses of EPA and DHA that were applied in the studies you showed, whether they are realistic for an everyday intake in older adults.
So I think the answer to that, Claire, is obvious. These are not realistic intakes for everyday intake. Some of them, I think, can be realistic in a clinical situation where there might be products available that can deliver high amounts of EPA and DHA, 2 to 4 grams per day. But I think a study using, 6 grams is not one that's easily translated into real life, for sure. Okay, sorry. There is another question about the source of EPA, DHA that you recommended. Either food or supplements. So all of those studies use supplements of one sort or another. So they could be like fish oil capsules, or some of them, particularly the studies in patients that were in the meta-analysis, would have used oral nutrition supplements, for example. So SIP feeds that are fortified with fish oils. I saw there was a question about fish oil versus algal oil. Pretty much all of these studies will have used fish oil, but algal oil is, you know, an alternative to fish oil. For me, omega-3s are omega-3s. It doesn't really matter whether they come from fish or algae. Once they get into the body, they still have the same biological effect by and large.
Okay. And there is also a complementary question of the dose, on the dose, especially about the minimum that is required in elderly, and whether it must be EPA plus DHA or only DHA. What do you think about that?
Yeah, I mean, these are great questions. And of course, people have been asking me these questions for like 25 years now. So first of all, the question of the minimum dose. So for free living people, the recommendations within Europe are anything from 200 milligrams per day up to 650 milligrams per day, depending on who is making the recommendation. My own view is that that is not enough. I think people need at least 1 gram of EPA plus DHA per day. So I think the recommendations are a little bit conservative. Of course, it's hard for people to get those doses unless they eat a lot of fatty fish or take omega-3 supplements. The second question is really, is it EPA or DHA? And the answer is we don't actually know for sure. Both EPA and DHA have biological actions. They're both anti-inflammatory. They both give rise to specialized pro-resolving mediators. They both lower triglycerides. They both lower blood pressure, et cetera, et cetera. They don't always have the same potency, but they both have biological activity. Of course, DHA is very important for brain development and brain function.
Okay, there was a last question about the link between omega-3 and the efficiency to treat chronic fatigue syndrome. I don't know if it's in the scope of your talk, perhaps.
To be honest, I don't think I can comment on that without looking at what's in the literature. It's not something people talk a lot about, but it could be an extrapolation of what I mentioned about fatigue. And I saw there was a question about mitochondrial function, and there are some studies on omega-3s improving mitochondrial function. So all of this could be related to this chronic fatigue syndrome.
Yeah. Okay, there are other questions, but it's time now for the next presentation. So perhaps we will come back a little bit more after. So the last overview will be about protein intake, higher protein intake to prevent bone loss during energy restriction. So the speaker is Shapses from Rutgers University in New Brunswick in USA. Sue Shapses is professor in nutritional sciences, and she works on the nutrition and endocrine regulation of obesity and osteoporosis. And she also focuses on weight loss induced changes to gut peptides absorption, and also on bone using intervention trials. So I give her the floor now. Thank you.
Thank you very much, and thank you for the invitation. Let me share the slides. Oops, any conclusions? Well, just let me know that this looks okay, or Philip, since you're there. You can see the slides.
Yes, it's okay.
Yes. Thank you. So it's a pleasure to speak to you today on the topic of protein and bone, focused on energy restriction or weight loss. And briefly, I'd like to just say why bone. We've heard a lot about muscle, and it's an interesting topic. Well, osteoporosis causes some statistics, greater than 8.9 million fractures a year. It's a fracture every 3 seconds, as it's stated. And this is an aging webinar, so it makes sense to focus on both muscle and bone mass, because both are part of the major or 4 domains that define aging. So now I'll say why energy restriction. There was a time when it was thought that bone was spared during weight loss. Not true. It does take a long time to see the response of bone, so maybe it was missed along the way. But we've shown at this point that bone indeed is lost, but there's populations that are more vulnerable, and there's interventions that can attenuate this. But overall, we need at least 6 months of studying or an intervention or to see an effect on bone due to the longer turnover time of the bone remodeling unit. Okay. So here I show you that low protein is not good for bone. And this probably doesn't surprise you. Overall, you can see that decreased bone mass occurs, and there's a microarchitecture that's damaged. This is shown in rodents. And in older adults, there's a number of different studies, but I chose the one by Hannon, and you can see that the lowest protein quartile here is associated with the greatest 4-year bone loss. So it's pretty strong evidence that there was an issue. Now I want to bring up hypercatabolic patients because they're in marked negative nitrogen balance. And it turns out that when we studied them, and again, this is the long-term ICU patients that look worse and stay in for longer, are more catabolic, they also have markedly high bone resorption and breakdown. So now we know that when they're in negative nitrogen balance, they're most likely in negative calcium balance too. And this was an early study that was done with some patients that I had studied in my PhD long ago under a different name. So I put a thumbs down for this. Now, with high protein diet, I'm going to tell you that there's some thumbs down going on for this. For a long time, humans were fed these studies with high protein diets. Actually, Herta Spencer, she would give high meat diets and she'd find hypercalciuria. And everybody knew about these studies. And Bob Heaney said that doubling protein intake increases urinary calcium. But then he came around and was an advocate for remember the calcium. And I'll get to that as we go along. Also, we know that net acid production, sometimes abbreviated NEAT, it increases protein within protein intake, and it's associated with a decrease in bone mineral density, as you can see here in the image on the right. But there's lower bone mineral density with higher NEAT. And finally, I'm going to mention that there was a large study that was derived from 16 countries showing a very strong relationship between dietary animal protein intake and fracture rate. So we didn't think protein was very good for bone for a long time. But it didn't seem like there seemed something wrong with the literature. First of all, it wasn't studied well enough. So a very early study in our lab was a short-term one where we gave very high levels of protein, but we gave it with adequate calcium. And we did not see a rise in bone resorption compared to the lower protein. But again, it was a short term, it was 5 days. But afterwards, Kerstetter, who was a colleague in the field with Carl and Sonia, said, we're going to do a real study on this one, inpatient study. And they looked at calcium absorption, because if you're excreting more calcium, well, perhaps maybe you're also, your absorption is modified. And no one studied it before. And so I give you the answer here, that there was an increase in calcium absorption. So from lower to higher protein, you can see the rise in this study. And they showed that calcium balance was actually not compromised. We also know that IGF-1 and IGF-BP3 is beneficial to bone, just like with muscle. So it's known to increase with protein. And there's also direct effects of protein on the osteoblast. Finally, I'm going to say that with protein supplementation in the elderly, they show who were sick in the hospital, they show that it reduces bone loss. And in rodent studies, there was support for this too. Now, stepping back to the topic of weight loss and protein, why was protein so popular? Well, many of you know that a decade or more ago, we realized, oh, it doesn't have to be these standard diets with higher carbohydrate all the time. So higher protein diets were popular, and I'm showing you the classic studies, the first ones, very large studies that were published. There's obviously many, many more. But here you see there was greater evidence of greater weight loss, fat loss, less lean body mass loss at 6 months. It was attributed to greater satiety and adherence, but it was not at 12 months. And then another study that came out years later, for 2 years, it was not shown for this either. You can see here at 24 months that there was no difference between the groups. And here are their groups. They didn't just study 2 levels of protein. They looked at 2 levels of protein and a range of different fat, but no difference between these diets. They suggested that it was really a matter of the number of sessions that predicted weight loss. So what about bone? It wasn't studied in these trials, and we needed some information about what protein was doing to bone. We learned that the hypercalciuria was accompanied by an increase in absorption. So we didn't have any data, intervention trials with bone. A great study that was done, very carefully done, inpatient metabolic study during caloric restriction is the following. This was done by J.J. Cow. And what he looked at is 3 levels of protein, 0.8, 1.6, 2.4 grams per kilogram per day. So 2 times, 3 times the lower dose. And it was a 30-day inpatient study. There was energy restriction, there was calcium supplementation with D, so they weren't compromised that way. And I'm just going to go to the conclusions and tell you that the higher protein was not detrimental to calcium homeostasis in this short-term, since it's 30 days, inpatient study. This is great information for the field when this came out. But we wanted to know more about how it affected bone and long-term studies. And so a study in our lab, and I'm just going to show you this very quickly. This is all the different bone sites that I show you here. This was higher protein intake during a 1-year weight loss study in older women who are the ones that were most at risk of losing bone during weight loss. And you can see with the darker, higher protein intake, which was 24% of the calories, that there was an attenuated bone loss that became significant at multiple bone sites compared to what we're calling normal protein intake of about 18% of the calories. Okay, so we were feeling like maybe this is the case. It was one of the first studies that came out. And we had some evidence of why this might be occurring. We found that in the higher protein group, there was higher IGF-1, circulating IGF-1, higher circulating IGF-BP3, and there was estradiol did not reach significance. It trended towards higher. But most importantly, there was also lower bone resorption in the higher protein group. Okay, so this supported the attenuation of bone mineral density loss in the previous slide that I just showed you. But not all studies show that. So I do want to show you another study. It was longer term and 2 years. And what they found here is that there was no beneficial effect of protein compared to lower protein. That was their conclusion in the abstract. But when you looked at the study a little more carefully, you saw that there were small differences between these groups due to a problem with compliance. They wanted it to be much wider, but it did not work out that way, which when we do human studies, we're all familiar with that problem. But this was very marked, where it was 77 versus 90 grams per day. And the 2 levels of protein intake, surprisingly, were both above 1 gram per kilogram per day, which in our population wasn't easy to achieve. So I think it was a time when people were very anxious about getting enough protein. and it was no longer possible to do a study of the two levels they anticipate. In any case, the concern is that it was not powered to detect 13-gram difference in protein. As most of us know, this is a very small difference. And it's possible that there's a threshold effect at 1 gram per kilogram per day. Okay, so let's move on to dietary protein and bone health with a multiple number of studies looked at it in a systematic review and meta-analysis. And what you see here is that at the hip, at the femoral neck, just part of the hip, there was no effect. Okay. And with the lumbar spine, there trended to be a positive effect. So the conclusions were that there were no adverse effects of higher protein. Again, we're trying to prove that in the field still, only that the lumbar spine showed a slightly positive effect of higher protein intake. And so this took all the studies, including the two that I just mentioned to you, into account. But as you can see, the studies differ and vary quite a bit. So whenever you look at meta-analysis, remember to look at the individual studies to make sure you know what you're looking at. Okay, and then finally, the next question by the same researcher and group that I was part of, we looked at animal versus plant protein. And indeed, we thought that possibly the isoflavone rich soy protein would have a beneficial effect on bone, but indeed there was no difference between animal or plant protein. And I say no evidence of soy protein because these studies were all based on soy protein or plant protein studies. And I do want to mention here, at the bottom, you can see there's no effect of protein source also on fracture. Another meta-analysis was done by Darling et al. And showed the same thing, that plant or animal, it did not make a difference, but there was no detrimental effect. Well, let's talk about individual amino acids, because maybe we're looking at the wrong thing. And here is a very interesting study where you can see that Paracelsus group gave a low protein diet to older mice. Never good. We've shown this multiple times in the field, but he found that it was prevented by the addition of aromatic amino acids. Now, is there any evidence in humans? Because this was done a few years ago now, but no, there was no association in a large study that was done with aromatic amino acids in hip fracture. But then they looked at a subset of elderly individuals with low dietary intake, and they found that it was associated with hip fracture. Now, this is cross-sectional data, so it needs to be confirmed by intervention trials, but it's very interesting. And of course, this population would be at risk of hip fractures as opposed to a larger and younger population. So I find it quite interesting, even though it is a cross-sectional study, indicating that we need to know more. In a very recent study that's in press, I'm told it will be published this week, what we did is we took all of our weight loss studies, and we had many of them, we combined them together, and we wanted to see whether or not lower or higher protein intake influenced diet quality and lean body mass in this study. And what we found, well, first of all, let me tell you the two different levels of protein. It was 58 versus 79 and 0.8 grams per kilogram per day versus 1. It was a middle-aged population, middle-aged to older population, and they were generally overweight. Okay, BMI of 29. So what did we find? We found that diet quality increased with higher versus lower protein intake. And we were very surprised by these findings. We knew that diet quality improves with weight loss counseling. We've seen this many times in the field, but here we were able to see that during the weight loss, it improved even more in the higher protein than lower protein diet. We found this very interesting. I show you all the food components here. And specifically, I'm going to mention that it increased the categories of greens and beans and reduced intake of refined grains and showed trends for lower added sugar, more dairy, etc. So we also found that, and this may not be as surprising, but the two talks before this, especially Everson's talk on protein, it attenuated loss of lean body mass. But again, remember that this is during weight loss, and this was self-selected protein intake in older people who would be at risk. And you could see a significant difference in lean body mass, but no difference in body fat loss in these individuals. Again, and there was also no significant difference in weight loss. So this was only attributed to lean body mass, the differences between these groups. So this was very interesting. But as you can see, much higher levels of protein was spoken about earlier in the webinar. And here we have, again, they're self-selected, a 0.8 versus 1 gram per kilogram per day. So I'm going to go on to my conclusions at this point and let you know that inadequate protein intake is always a concern for aging. It's bad for muscles, it's bad for bones. But we know that moderately higher protein intake does not cause osteoporosis. And in fact, we have some data to suggest that at least 1 gram per kilogram per day increases IGF-1, improves diet quality, benefits lean body mass, and I say may attenuate bone loss. I say that because of the meta-analysis, but when I showed you some of the differences between some of the studies, you agree that if you don't get compliance, you're not going to get results. So this is very promising information. And at the last minute, I said, wait, I got to remind everyone you need adequate calcium and vitamin D all the time when you're doing studies with bone, because if you don't have adequate calcium and vitamin D, your results will be markedly different. And that's what was happening early on when there was hypercalcemia with the studies, and showing also that there was negative effects of protein on bone. So now I'll say that there's no current evidence to show a difference in plant or animal protein on bone, but this hasn't been studied adequately during weight loss. And finally, controlled long-term studies that focus on doses. Maybe we need to look at doses higher than 1 gram per kilogram per day. That hasn't been studied in the field. And remember, the studies for bone need to be longer, so there has to be compliance along the way. So these are not easy studies to conduct. And we do need more information about protein source or amino acids and their effect on bone. So with that, I'll say thank you very much, and mention some of the support that I've had, many of the people who helped, and of course I'm open to any questions at this time.
Okay, thank you very much, Sue, for this very complete overview. For the moment, I don't see any question in the chat. So before the questions are coming, I have several ones. Perhaps regarding our aromatic amino acids, how would you explain a specific effect of these amino acids on bone mass?
So no one has studied that. I think it's a very new field, and it's going to take a lot of funding in order to address a question like that. There's amino acids that are specific for calcium sensing, and some of those were studied by the Insomnia group, Arsteta and Insomnia group. And they were finding mixed results. So those amino acids became less interesting. And then the aromatic amino acids that I mentioned here became a little bit more interesting. And I think we'll have to find out in the future if there's any specific effects of intervention trials on bone mineral density. And certainly we want to know more about fractures always, because that's the end result that's most interesting in the field and most important.
Because in this study, when you were on this slide, when you mentioned the people who had the lowest, lower intake of these specific amino acids, how was it done? It was observational studies on food intake and with the.
Okay, so that was one of the last studies that I looked up. It's not, it's a cross-sectional study, so I always hesitate to put too much weight on those studies, but it was done with dietary intake. It wasn't a sophisticated study, which is simply another reason why we should start thinking more about it. And I don't know if there's going to be a significant effect.
And you did not much mention the cohort EPIC Oxford study that was that has been published 1 or 2 years ago about the link, the bone health in vegetarian people. What do you think about this this study showing that even in vegetarian people you can have an increase of some osteoporotic fractures?
Mm-hmm. So that's a really interesting topic and really important. As more people go plant-based, we need to know more about vegetarian food habits on bone. We don't know enough, and these studies that I mentioned to you are not, are really not, they're just the beginning of understanding this. So we do know that vegetarians who consume dairy, their bone is no different than omnivores. Vegans, the data shows consistently that there's greater fractures. Now I don't want to say that without commenting that early on, the vegans weren't, it wasn't as popular. And I really think that this will change as people are more conscious of their diet, the minerals and vitamins that are necessary to take with a vegan diet. And in fact, we're writing a short review on this, and it's very on my mind, let's put it that way. And we're going to think more about it. But we want to come up with positive ways that people who choose to be vegan would not be at risk. And indeed, only in the future will we know that people who are vegan today are not as at high risk. And then I'm going to say one more thing, that body size is very important for fracture risk. And certainly people who are smaller are going to be at higher risk. And we know that vegans tend to be on the leaner side. So we need to take all these factors into account and compare them to other people who are lean.
Okay. And maybe I have an additional question. So indeed there was a controversy about the effect either detrimental or beneficial of high protein diet on bone health, and maybe it seems to be neutral, but I think there are some studies showing that when the calcium intake is low, it's not good to have a high protein intake. What do you think about that?
It's, it's something that people don't really think about when they have high protein intake. And I know that Everson was recommending much higher intakes than what we've studied in the field of bone. And I'm not sure if we could go as high as 2 or more than 2 grams per kilogram per day, but indeed that inpatient study showed that it was perfectly fine. So I'm going to ask you, Claire, what was the question that you were asking?
Yes, so sorry, it was between the association of a high protein intake and a low calcium intake that could be detrimental.
So, with all these studies that we're doing, whether it's bone or muscle, we need to think about adding calcium. So what is the exact amount? Maybe you're asking, let's give some advice to people. If people consume the recommended dose, it seems to be fine. In our studies, we were studying differences between the recommended dose of 1 gram or 1.2 grams per day, depending on the age of the participant, and 1.7 grams per day. We were able to attenuate some of the, well, I'll say they were in positive calcium balance when they were able to get up to 1.7 grams per day. So one of the things I didn't mention to you about weight loss is during weight loss, people decrease their calcium absorption. I don't know why that happens. It's a terrible reaction that our body has. So you do need a little bit more calcium. So I would tell people at least 1.2, possibly up to 1.5 grams per day when they're dieting and when they're consuming at least 1 gram per kilogram per day of protein.
Okay, thank you very much. Are there any questions from the participants regarding this talk? I think there are no.
I'm going to ask Everson a question if he's still there.
Yep.
How
Yeah,
long are the studies with muscle? And I just want to know, you know, I was showing the studies of how 6 months, higher protein, great weight loss, but then afterwards, no. And in bone studies, as you know, we need to go at least 6 months. So I wanted to know your thoughts about timing and muscle.
Yeah, that's very interesting, Professor, because like most of the studies, like the ones that we got in this review, they lasted like between 8 and 12 weeks actually. So they are, I would say, short-term studies, like 3 months, and this is like 80% of the studies. And but one thing that I was thinking about listening to you right now is that because most studies they use animal-based proteins as well, and most of these proteins they come from milk, so the supplements, or when you are adding protein sources to the diet, they usually have some calcium as well, and they have like a high amount of calcium. So maybe if you try to investigate some of the subjects during these studies, they're not going to go they're not going to have any like negative calcium balance, because you're giving them a lot of calcium in the protein sources you're giving them as well, right? So maybe that's something to account. Yeah,
that's good to hear.
Yeah. But I agree with you that like for protein, at least for the randomized clinical trials, you don't have long trials. Most of them they are like 3 months or maybe less than that, depending on the design. Yeah.
And are you aware, there is a question in the chat of studies that combine the effects on both on muscle health regarding higher protein intake? Because generally we have separated the studies either on muscle or either on bone.
Yeah, and what I see is that like a lot of papers where they are trying to investigate the protein effect, they usually some of them they can use like DEXA to analyze body composition, and you have in some papers the bone density there as well and the bone mass, but is not usually the main target of the paper. So even if you read the results, people don't talk about that much, and I really don't know if they are getting like high quality data to work with the data as well. So just because it's not the aim, right?
I'm going to say most of those studies you just said are very short term.
Yeah.
Bone turnover takes about 4 months.
Yeah.
So they are too short to ask that question.
Yeah.
But why don't I guess what I'll say is that in the studies that do longer term, and in the study that I presented from our lab, we saw, I don't remember in that original study what we saw. We needed to, it wasn't powered to look at muscle, but I think we saw an attenuation. And then of course we retrospectively looked at all our studies, and certainly we saw a difference. And we're going to start looking at all the bone in these studies too. Just takes a really long time to gather all the data from different studies that were in the same lab. They're called the OWL database. And they were conducted in the same way, but we'll get to that question as we continue to do research in this field. It's really crazy that we don't combine it and ask the question together as a primary outcome. Thanks for whoever asked the question.
Okay, if there are an additional question before closing the webinar from anybody? Okay, so there is not. I'm looking, I have a message. Yes, so I have to remind to people that they can reach the speakers directly. I think you have the emails of the speakers. And so I thank you all the speakers for their very interesting overviews on these questions. And we see that there are often some questions about the level of protein that is useful, but also on the quality of fatty acids and lipids, and that I think that we can wait some new studies and also epidemiological studies. Then I will end this meeting just by sharing an information for the ILSI. Sorry, I will share my screen for the next meeting. I don't know if you see my correctly my screen.
Yes.
On the next meeting, sorry, that will be held in Lisbon, in Portugal, and the meeting is on nutrition for the aging brain, from mechanism to sustainability, and it is open for inscriptions. And so I think we will leave everybody, and I thank you once again the speakers and also the participants for their very interesting questions.
Thanks everyone for coming. Yeah.
Have a great day. Thanks. Yeah.
Thank you.
Good afternoon, everybody. Bye.
Thank you, Claire. Good afternoon.